हेलो एवरीबॉडी, वेलकम ऑन माय स्वप्नाली एस जाधव चैनल। कैसे हो आप सभी? ड्यू टू सम पर्सनल रीज़न आई कांट गिव नेक्स्ट पार्ट ऑफ वीडियो ऑफ न्यूक्लियर केमिस्ट्री टॉपिक अर्लियर। ओके, बहुत दिनों के बाद हम मिल रहे हैं। अगला पार्ट मैं आपको जल्दी नहीं दे सकी। सो इन लास्ट video we see nuclear fusion, and in that video we started nuclear fission reaction. So what is mean by fission? Fission means break. Fission means what? Break. So when break, then what happen? One part is converted into two or more parts. So what is mean by nuclear fission? So we see first definition of the nuclear fission: the process of splitting of heavy nucleus into two or more nuclei of approximately equal atomic weights with release of large amount of energy. Is called nuclear fission. Okay, the process of splitting of heavy nucleus into two or more nuclei of approximately equal atomic weights with release of large amount of energy is called nuclear fission. Okay, so nuclear fission was discovered by Otto Hann and F. Strassman. When? In 1938. Who discovered the nuclear fission reaction? Otto Hann and F. Strassman. When? In 1938. So which reaction they give? That is uranium 92-235 absorbed neutron. Then there is formation of barium 56-141 plus krypton 36-92 with release of 3 neutrons and large amount of energy. That is how many? 200.27 million electron volt. Okay, this reaction was given by the Otto Hann and F. Strassman. That is uranium 235 absorbed neutron, then it is converted into barium 56-141 plus krypton 36-92 with release of 3 neutrons and large amount of energy, that is near about 200 million electron volt. And further, the Fritsch and Mittner in 1939 used the term nuclear fission. Okay, the reaction is always accompanied by neutron emission and there is mass defect, and these mass defects appears in the form of energy. So according to Einstein equation, E is equal to mc square. Mass defect is converted into energy. Energy released and number of neutron produced may be different per fission. Okay, energy released and number of neutrons produced may be different per fission. The characteristic feature of nuclear fission reaction is that every nucleus first absorb one neutron. Every nucleus first absorb one neutron and emit two or three neutrons, and emit two or three or more neutrons called the secondary neutrons. These are known as the secondary neutrons. Okay, these secondary neutrons further bombard on other heavy nucleus and forms a chain. These secondary neutrons further bombard on other heavy nucleus and forms a chain. Okay, how chain is formed? We see. So the characteristic feature of nuclear fission reaction is that every nucleus first absorb one neutron. Every nucleus first absorb one neutron and emit two or three neutrons. Here emitted 1, 2 and 3 neutrons. Okay, then what happened? That neutron are called as secondary neutrons. These secondary neutrons further bombarded on other heavy nucleus, further bombarded on other heavy nucleus, that is uranium. Okay, and further form barium krypton, and emits how many total neutrons? 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 neutrons are emitted. 9 neutrons are emitted. That neutron further attack on other heavy nucleus. Further attack on other heavy nucleus and forms barium krypton, and other neutrons are emitted, and such forms a chain, and such like that it forms a chain. Hence on an average 2.5 neutrons and approximately 200 million electron volt energy is released per fission. Per fission, how many energies released? That is 200 million electron volt. Okay, so here chain is formed, hence this reaction is known as the chain reaction. This reaction is known as the chain reaction. So what is mean by chain reaction? What is mean by chain reaction? The reaction in which product acts as reactant of further reaction. The reaction in which product acts as a reactant for of further reaction is called the chain reaction, and this is the self-sustained or self-propagated chain reaction. So what is mean by self-sustained or self-propagated chain reaction? Chain reaction which continues without a break, which continuous without a break is known as the self-sustained or self-propagated chain reaction. To this chain reaction, energy of fission reaction is found to be enormous, and this energy can be used for two purposes. First one, for peaceful purpose. In reactors for energy generation. Peaceful purpose kasha in what? Reactors. In reactors for energy generation. This is known as the controlled fission reaction. Controlled fission reaction, and other is for destructive purpose. Other is for destructive purpose in the form of atomic bomb. Atomic bomb. So in atomic bomb, uncontrolled fission reaction. Uncontrolled fission reaction. So energy is in tremendous amount released. Energy released in tremendous amount. So how many energy released? So it has been estimated that energy produced by the fission of 1 gram uranium 92 235 is same as the burning of 2.5 metric tons of good quality of coal. How many energy is released when we burn, when 2.5 metric tons coal, when we burn, good quality of coal is burned, then that coal given what amount of energy is equal to given by only 1 gram of uranium 92 235. Okay, understand? This is about the nuclear fission. Okay, so what is the definition of nuclear fission? The process of splitting of heavy nucleus into two or more nuclei of approximately equal atomic weights with release of large amount of energy is called nuclear fission. So who discovered the nuclear fission? That is Otto Hann and F Strassman when in 1938. So which reaction he gave? Uranium 235 absorb when 1 neutron, it is converted into barium and krypton with release of 3 neutrons. Okay, and large amount of energy. How much? That is 200.27 million electron volt of energy. Okay, then what we see? The reaction is always accompanied by neutron emission and there is mass defect. This mass defect appears in the form of energy, and according to Einstein equation, that is E is equal to mc square. Okay, so energy released and number of neutron produced may be different per fission. The characteristic feature of nuclear fission reaction is that every nucleus first absorb 1 neutron and emit 2 or more neutrons called as secondary neutrons. These neutrons further bombarded on other heavy nucleus and forms a chain. Okay, so chain 5, it is called a chain reaction because the reaction in which product acts as reactant for further reaction. And it is also known as self-sustained or self-propagated chain reaction because this chain reaction which continues without a break, it is known as the self-sustained or self-propagated chain reaction. So on an average 2.5 neutrons and approximately 200 million electron volt energy is released per fusion of uranium 235. Okay, due to chain reaction, energy of fission reaction is found to be enormous, and this energy can be used for peaceful purpose in reactors for energy generation. This is controlled fission reaction, and for destructive purpose where in the form of atomic bomb, and it is uncontrolled fission reaction. Okay, and remember that 1 gram of uranium 235 produces energy same as that of burning of 2.5 metric tons of good quality of coal. Okay, understand? The energy released due to mass defect could be calculated. How it is calculated? Mass defect is equal to mass of reactant minus mass of product. Mass of reactant minus mass of product. Okay, and for example, mass of reactant, since mass of reactant is equal to how much? 236.133 AMU, and mass of product is equal to 235.918 atomic mass unit. Then mass defect is equal to mass of reactant minus mass of product. 236.133 minus 235.918 is equal to how much? 0.215 AMU, atomic mass unit. Therefore, energy released is equal to mass defect into 931 million electron volt is equal to 0.215 into 931 is equal to 200.165 million electron volt. Okay, so mass, remember the formula of mass defect, mass of reactant minus mass of product, and energy released is equal to mass defect into 931 million electron volt. So to explain the phenomenon of nuclear fission, scientists use liquid drop model. So which scientist gives the liquid drop model? Bohr and Wheeler. Bohr and Wheeler used a liquid drop model to explain the nuclear fission. Okay, nuclear fission. So according to them, nucleus behaves like a liquid drop. Okay, this is spherical. Suppose this is A. Okay, liquid drop. So when a neutron is absorbed by a spherical nucleus, it becomes highly energetic, and Coulomb's repulsive force disturbs the spherical shape into ellipsoid shape. That is like that. That spherical shape is become which shape? ellipsoid. Suppose this is B. Okay. Then next, what happen? Further, if forces are large enough, then ellipsoid shape is converted to dumbbell shape. Ellipsoid shape is converted into which shape? That is dumbbell shape. Okay, this one is the which shape? Dumbbell shape. Suppose this is C. After dumbbell shape, what happened? And finally converted into two major drops. So how it is converted? That is, here critical state is attained. This is the critical state. Suppose this one is D, and finally two major drops are formed. The energy absorbed by nucleus to change A to D, is called threshold energy. A to D is called threshold energy required for the nuclear fission process. Once the stage D is approached, it is unavoidable to break into stage E. The energy associated with stage D is known as critical energy. The energy associated with only stage D is known as the critical energy. This is about the liquid drop model. So who give the liquid drop model? Bohr and Wheeler. Why? To explain nuclear fission. So according to them, nucleus behaves like a liquid drop. When a neutron is absorbed by a spherical nucleus, it becomes highly energetic, and Coulombic repulsive forces disturbs spherical shape into which shape? Ellipsoid shape. Then further if forces are large enough, then ellipsoid shape is converted to dumbbell shape, and finally dumbbell shape is converted to two major drops. Okay, here say in each stage. Okay, the energy absorbed by nucleus to change from A to D is called the threshold energy. Okay, threshold energy, and the energy associated with stage D is called critical energy. Thus energy released due to mass defect. Okay, understand, this is related about the liquid drop model. आई थिंक आपको ये वीडियो अच्छी तरह से समझ गए होगी, आपको न्यूक्लियर फिशन और लिक्विड ड्रॉप मॉडल अच्छी तरह से समझ में आया होगा। अगर किसी को कुछ डाउट है तो कमेंट बॉक्स में कमेंट कीजिए, आपके लाइक कीजिए, आपके दोस्तों को शेयर कीजिए, और अगर अभी तक किसी ने मेरी चैनल को, स्वप्नाली एस जाधव चैनल को सब्सक्राइब नहीं किया हो तो सब्सक्राइब कीजिए। ओके, ताकि आपको आने वाले वीडियो जो है वो जल्दी से जल्दी मिल सके। थैंक यू वेरी मच।